Good day again. Today we are going to talk about parallel lines and perpendicular lines, if I can pronounce that properly, and how are they related in terms of the components of each of the lines. If two lines are parallel, what can we say about them in terms of y-intercept, slopes, and also if they are perpendiculars, what can we say about that? All right. First, I gave you two lines on the grid. And the first thing is that let's go ahead and come up with the slope of each line. Can we do that? That's the very first thing we need to do. So let's go ahead, you pause this video and come up with the slope of both lines and come back and continue. I'll do the same. Okay, so here we have set up two lines, L1 and L2, and you can use any part of the line to come up with the slope. Notice that I chose that point. I know exactly where that point is, -6. So from that point I go up and then across and I hit the graph again, and then you can keep doing that until, you keep doing that and then you check that it's going to land on the line again. And so as for L2, you do the same thing. So what is the slope of line 1, M subscript L1? What is the slope? The slope is rise over run. 2/3. What is the slope of line 2? That will give you 2/3 again. Excellent. Now if you keep doing that, you notice that the slope of each one stays at 2/3, and it doesn't matter how long the line is and how far you go, you will always have 2/3. And you notice that the distance between the two lines will never ever change. It always stays the same. And whenever you have a setup like that, we say that L1 is parallel. That's a symbol for parallel lines, parallel to L2. So this means parallel lines. Okay, two lines are parallel. All right, and the only way that you can say that two lines are parallel is when their slopes are the same. Y-intercept has nothing to do with it. As you can see, the y-intercept of L1 is 4, y-intercept of L2 is -2. They're not the same, and they don't have to be the same. All right, so really you can actually move this line anywhere up and down. As long as the slope is the same, they're parallel to each other. So look at this example. We have two equations of a line, of two different lines, and we want to know if they are parallel to each other. This time you don't have a graph. All right, so but you do know that the only way these two lines are the same or they're parallel is that the slopes must be the same. So let's call the first line L1, we call the second line L2. So let's come up with the slope of each one. Notice that the equation 1, line 1, is not written in a slope-intercept form. So we need to come up with a way to get the slope from that. And the only way is that you rewrite it in terms of y equals mx plus b, which is this form right here, and then read off of the equation the slope. So go ahead and rearrange that equation in terms of y. That means it has to be written as y equals to. And you know how to do that. You have to move the 2x to the other side and isolate y. Let's do the math and come back to it quickly, and that would be it. Okay, and now we have, so went through 2x, subtract 2x from both sides, we get 2y equals to -2x plus 1, and then you have to divide both sides by 2 because we want y on its own, isolating y, and y equals minus x plus 1/2. That's the equation we have. The next equation we had, y equal to -x plus 1, that's the equation of L2. Now you compare. What is the slope of line 1? This is -1 in front. Now we don't put 1 in front of it. If it doesn't show up, that's a 1, remember, by convention. So the slope is -1/1 or -1. What is the slope of line 2? Same thing again. So here we have -1, and we also have -1 as well there. or negative 1 in front like that, and that would be negative 1. So are they parallel? Yes, because they are equal to each other. That is it. We don't really care about the y-intercept. Y-intercept could be different. Very good. That's basically it for that. So if two lines now are perpendicular to each other, what does that mean? Well, first, perpendicular means that they have to hit each other at 90 degrees. That's what perpendicular means. So cross at 90 degrees to each other. Okay, that's the first thing. That's the first thing. And the way you write it, by the way, L1, that's the symbol for perpendicular right here. That's the symbol for that, just in case you've forgotten your geometry notation. All right, and that's L2. That's how you say it. All right, now they are related to each other by their slopes, and here is the relation. It's a little bit harder right now to define that or prove that unless you get into a little bit higher grade, but basically is that when you multiply their slopes, you will always get -1. Okay, always get -1. Another way of writing it is that the slope of the first one is the negative reciprocal of the slope of the second line. Okay, that's a fancy way of saying that if you have the first slope is 2, the second slope ML2, if L1 is perpendicular to L2, the next one, the slope of the line 2, is negative reciprocal of 2, and reciprocal of 2 is 1 over 2, and that's what that is. Now if you multiply, let's check. What is 2 times -1/2? Well, that is -1. And that is what you will use to check if two lines are perpendicular to each other. Simple as that. Let's look at another example. Let's suppose we have two lines. They are perpendicular to each other, and the slope of the first line is 3/2. What is the slope of the second? Well, remember, negative reciprocal. That's the fastest way. First of all, what is the reciprocal of 3 over 2? So ML2, the first thing you have to do, you have to flip the 3/2 to become 2/3, and remember it's negative reciprocal, so you put a negative in front of it. So that's it, and then you check, is 3 over 2 times -2/3, is that equal to 1? 6 minus 6 over 6, is that equal to, sorry, that should say -1, -1. Well, it is. -1 is equal to -1, and yes, therefore the slope of the ML2 is -2/3.